All right, good afternoon, everybody, on our last day. Well, we have a test tomorrow, but pretty much our last day. It's either happy or sad, I'm not sure which. Like always, please check your background noise and either use push to talk or mute your microphone if you know you're not gonna say anything. Thank you for verifying that everything is working. We are talking about some algebra. Now, we're not going crazy with the algebra. We're not doing calculus or anything like that. That is a good time as well. We are just getting an idea of the basics in case we are in a grade 7, maybe 8, you never know, situation where we are starting to cross over to a more algebraic way of thinking with symbols for numbers uh, and so on. But at our level, it's very much a translation issue. We have a situation like, where are we now? Exercise 16.6, a situation described in words, and we want to represent other quantities in a mathematical language. The first step towards equations and things like that. So it's very important to be able to do that translation first, that if I define a variable representing a certain quantity, can I use that variable to represent other quantities related to it, an algebraic expression, before we worry about the equation aspect. An equation aspect is just really two algebraic expressions that represent the same thing, and so their values will be equal. I still need to be able to do that translation aspect of it. Then in exercise 16.7, we have the full equation where it's still just the translation. And things like number 2, it's very important to understand how we get to an equation and how we've translated the information. And it's the same thing really over and over and over. All of these are in the videos, I know for a fact. And what was I going to say? I was going to say something. No, never mind. Don't know. And then we have some problems as well. And you see the way of thinking that it repeats itself over and over in that translation sense. And once I've translated the information to an equation, then I am in this mathematical language where I can focus on the rules for simplifying those kinds of sentences. Problem 16.3. 16.3, yes, let's have a look. Now, what are the two favorite things in elementary school or middle school? They are word problems and fractions. So the best time is when I have word problems involving fractions. Doesn't get any better than that. Jim, Ken, Len, and Max have a bag of miniature candy bars. Jim takes a quarter of all the bars, and Ken and Len each take a third of all the bars. Max gets the remaining 4. Now, what might make this kind of problem, especially 16.4 as well, easier is to break it up into smaller pieces when things get a little overwhelming. Instead of just trying to write the equation as the first thing you're writing. It might be nicer to break this up. So let's see a way that we can have words and make sense of this. Because it might not be a variables and equation question every time. It might just be a calculation question. It depends. It depends. Let's see. One of the worst things I could do is going into a problem thinking it's going to be something it might not be. If I think, oh, I'm going to define some variables and I'm going to do it this way, well, this problem might not require that based on how the information is presented. I don't know. I have to go in with an open mind. So let's have a look. They ask how many bars were in the bag originally. Okay, well, let's give that a variable name. Let's suppose X will represent the original number of bars in the bag. Now, I might not have the best setup every time. I should feel free to go back and tweak it. Oh, maybe this is better. It's not going to be perfect every time from the beginning for every question. Okay, so let's see now. Jim takes a quarter of all the bars. So I'm going to write out some sentences here. Then Jim takes a quarter of X. That's 1/4 times X. You don't need a dot there because one of them is a symbol. You can just write nothing, and that implies multiplication. But this is a number of bars. Ken and Len each take 1/3 of all the bars. So Ken takes 1/3 of X, that's multiplication. And that is my algebraic expression to represent the number of bars that Ken takes or gets, whatever. And was it Len? Yes. Also takes 1/3. Gets 1/3 of X. Notice how many words I am writing. This is not the time to write less. The less I write, the more I have to keep track of in my head, and there's a lot of empty space. I need space for the bats to fly around. I don't have space in my head to keep track of all these things, so I write them down. Then if I look out the window, oh, it's a nice day. What was I doing again? It's all written down. Easy. And Max gets a remaining 4. Max gets whatever, 4 bars. So now we can say here, well, the total is what? The total number of bars, let's write that down. While you are thinking, I will write the sentence. Total number of bars, thinking times over. What is the total number of bars? It's not silence. No, it's going to be something related to a number. No. Any idea how or what the total number of bars will be? You came all this way, you logged in, you might as well say something. It's your last chance.
Wouldn't it be the sum of all that was taken?
Yes, but that's going to be the left side of the equation, where I need to essentially calculate the same thing in 2 different ways, giving me my equation. So one way is going to be doing them separately, like I listed, and then adding them up to give me the total. But I need another side. There has to be other information somewhere telling me what the total is without this individual, because I can't do the same thing on both sides. That's usually how it goes, not every time, almost always, for our level. I'm trying to represent the same thing in two different ways. One is in the broken up pieces way, which I then add. And the other one is in a different way, which could be given or something, but it can't be the same. And that will then create my equation.
Wouldn't it just be x?
It is just x, yes. It is just x. Now let me just check. What do they want? How many bars were in the bag originally? Well, if I solve this equation, then I would get the answer. Now, I'm not saying this is the only way, but it is a nice and consistent way. Step one, define a variable, usually in line with the question portion of the problem. Then I have some other quantities that I could represent with that. Then step two in my four-step process is to translate the information into a mathematical equation. And then step three is where I now work within that mathematical language with its own grammar and its own rules for simplifying sentences. And I essentially solve the equation. So I have one now. One way to solve this equation is, if you don't mind the fractions, just put all these guys on the left. They're all like terms. Put them together. So now a quarter I have to merge these fractions, right? So I have to put it over 12. It's not 1 over 12, but it is over 12. It'll be 3 over 12. And a third will be 4 over 12. Same for this one. So then when I put them together, how many x's do I really have? I have 11 over 12 times x, plus my 4 that didn't look like anything else, plus the right-hand side x that didn't look like anything else either. Now I'm just going to swap everything because I like the other side best for no reason whatsoever. I just like it. When one side is equal to the other side, then the other way around would also be true. Now I'm going to subtract 1 over 12x on both sides. As long as I do it on the same, as long as I do the same thing on either side, I'm good. Now here, of course, I have 1, which is 12 over 12. So I have 1 over 12 left, 1/12 of x, and I have 4 left on the other side. See this in many ways. I could just divide by 1/12 if I don't want to overthink this, which I don't. And so I get x equal to 48 because division by fractions is multiplying by the reciprocal. Shortcuts, which now we're not drawing rectangles. Now we can use those shortcuts or calculator or whatever. 48. And then my concluding sentence. There I guess, were 48 candy bars or chocolate bars in the bag. Now, I'm not looking at the answer key the way I wrote it. Who cares? To me, it doesn't exist. It's just there because some people complain if I don't have something. But it might be an old way. It might not be the same as this. I don't care. There's always updates happening. So the real thing is the nicest version, and we can tweak this as you need it to be presented, which makes it nicer. Real time. I sort of squeeze everything in. So that's not all the question, but it's a start. Any questions on the first part, at least? Notice there's some math, some algebra, but also a lot of words. A lot of words. So that anyone who reads it can understand and follow it to a degree without me being there. That is what we're aiming for. When you look at your answer, you think, Do I have to be there to explain to someone what my answer is? If yes, then you don't have enough words. You need more stuff. So regardless of the complexity of the question, for other problems, we have these 4 steps that you can focus on. And notice how at the end of step 3, I get an answer, a single number. A lot of things happen before I even think of the number. If you trust the method and the layout and the process, the answer is going to come out of that. I don't need to worry about the answer. But that's not how kids think. They want to know the answer right away. The method, the journey gets me to the answer. I don't need to obsess over it. Now, there's a number 2. How many bars did Jim, Ken, and Len each get? Well, now that's straightforward. You can then take this back in here, here, and here, and then say Jim takes this many, Ken takes this many, and so on. Let me know if I need to do it, but I don't think I need to. Totally fine if you want me to, though. I just plug in the value for x and calculate the representations for the individual amount of candy bars. Now, 16.4 is a little different, though if you read it fast, it looks almost identical. It is very much not. Jim takes a quarter of all the bars. Okay, that's the same. But then after that, Ken takes a third of the remaining bars. Len takes a third of the remaining bars after that, not a third of the original. So let's at least set that up so that everyone can see the difference, because I don't think there are any other questions right now. But feel free to interrupt me and say, no, switch to something else. No one asked me to do this one. I'm just moving on until there are new questions. "4 p.m. tomorrow, test time, and then you are done." Hopefully it feels good to be done. It definitely seems like the time has flown by more than usual. So, same start. Let x represent the original number of bars. This is not the place to write fewer words, write a full sentence. Then, who was first? Ken? Oh, no, Jim. Jim takes still a quarter of all the bars, so 1/4 of x. It's multiplication. Bars. Who's next? Ken. Ken takes a third of what's left. So what is left? X minus 1/4 x. A third of that. Bars. So because of the explanation they give me, the algebraic expressions to represent the number of bars is a little bit more involved. Len then takes a third of the remaining bars. So in that situation, a third of what's left after that, it might make sense to simplify Ken's amount first. Though it's not absolutely necessary. Might be nice, might be a good idea. So Jim takes an amount, Ken takes an amount. If I want to know what Len takes, it's a third of what's left. So I kind of need to know what's gone first, perhaps. So I multiply the third in, third x minus 1/12 x to get, well, a third is over 12. It's going to be 4/12. So I have 3/12. Really? No. Wow, that's interesting. Now, if I leave it like this, just to emphasize that they could be different, they just happen to be the same in this case. Coincidence. I have what's left before Len starts taking. Total amount minus what Jim took minus what Ken took. Yes, I can simplify this further and so on and so on. And then I can continue this to see, okay, what's left after that? Well, that has to be 8 bars. Or you can set up your equation like we did here. It's the same idea, right? The expressions representing the number of bars is just a little bit more complicated because the situation is more complicated. And so on. So I have to adjust according to the words in the question. I can't go in wanting it to be simple, and if it's not, it's not. There's nothing I can do. Or expecting it to be super complicated and then completely overthinking the maybe simple situation. I have to just let it be. 16.6. Yeah, all the words are on my screen. Bronwyn wants to buy a house, so she has decided to save 1/4 of her salary. Okay. Bronwyn earns $47 per hour and receives an extra $28 a week because she declined company benefits. She wants to save at least $550 each week. How many hours must she work each week to achieve her goal? When I read this through, at the end, I can honestly say with no shame, I have no idea what the answer is. But that's also not what I'm expected to know at the end. The answer does not come first. It's late in step 3. Why would I care about the answer now? I don't. I could not care less. I trust the method, the layout, the steps, and it'll get me to the answer eventually. So I focus on the question portion. How many hours must she work? Let's call it, what do you want to call it? Should we just stay with boring old X? Sure. Let X represent the number of hours worked, or that she needs to work, or whatever. You get the point. Now, maybe I want to say some more, represent some more things before going to my equation. Depends on the complexity of the situation. So maybe I want to write down the total amount earned per week. Is that something I might want? Well, they're talking about a week. And 550 a week. Everything's in a week. How many hours should she work a week? Okay, so the week is my time frame here. So that makes total sense. Total amount earned per week is represented by $47 per hour. She works for X hours, so 47 times X. Plus a little bonus of 28. See how I am not even thinking about the answer. I am just translating what they tell me. So that means that she saves what? Per week, of course. They tell me she saves or wants to 1/4 of her salary. So 1/4 of her salary. And slowly we're inching towards the translation, the full translation. And perhaps now I'm ready for my equation because they then say also she wants to save 550. So, oops, my full translation mathematical sentence is the amount she saves is represented in detailed form by that, and I want that to be the same as 550. Equation done. Do I care about the answer? No. I just set up the equation to translate and capture the information. Now within that mathematical language, I'll simplify. I don't love the fraction perhaps in this case. I can multiply both sides by 4 to get rid of that fraction. So 47x plus 28 is 550 times 4. I realize we haven't really typed anything in here. So let's get a calculation to show. And of course we get 2,200. Then I'll subtract 28 on both sides. Use your calculator, don't use your calculator. I really just use it so we can see something in the chat since no one is really saying anything. MathBot can say something. And we get 2172. Then we divide both sides by 47. Maybe it's a nice number, maybe it's an ugly decimal number, who knows? It seems to be an ugly decimal number. 46.2127659574468. Who cares? I don't want to round it here. I will round it in my concluding sentence. What was the question again? How many hours must she work? So now here you're translating it back to English. So you can be a little bit more, say, liberal with your rounding. You can argue that maybe she only works whole hours, then 46 is not going to be enough. So if we make that assumption, totally fine. She needs to work at least 47 hours. And in this case, connecting it to what we said yesterday, it makes sense. It's not even rounding. It's even more than rounding, taking in practical considerations. So I could say here, assuming she works whole hours only. So it's not even rounding. If I say she needs to work 46 hours, no, she's going to fall short of the 550. So it's rounding, but it's like practical rounding. I can't be blind to the practical situation, which is the whole point of this. Any thoughts on that? Does it make sense? Does it not make sense? Notice what's the same. Notice what's different. These are things I say over and over and over from the start. Ever since Lady and the Tiger, I said, build from what's the same. Build on that, maybe with little tweaks. Not every question is different. You've seen the steps before. The more you do, the more similarities you see. And that gives me confidence that I know next problem I'm going to do. I know what I'm going to do. I'm going to focus on a variable. And I'm going to start the translation. I don't care about the answer. Look how far down in my presentation the answer occurs. Is that something I need to worry about initially? No, of course not. Check net your agony though. Okay. So build on what's the same, build on or from that, and focus on the differences. A lot of these things are the same. I'm just rambling on since no one else is saying anything. This is your last chance to say something. You're going to sit there later tonight thinking, if only I said more, now I'll never have the chance again.
It
You're
makes
gonna.
sense. It just takes time and thought to do it slowly.
Oh, of course. Yes. Slowly is the key. And I see kids especially, they they read a question, they want to know the answer right away. And if they don't, that is a sign of weakness, and I guess they're just stupid, or their brain doesn't work that way, or some other excuse. But it's a completely unreasonable expectation. I read a question like this, if I've never seen it before, I have no idea what the answer is. I also don't expect it of myself to know what the answer is. But I trust the method. I know what I'm going to do, and I can walk towards the answer. If I keep walking towards the answer, it's going to happen. There's nothing to worry about. But taking a longer route is in no way a sign of weakness. I'm not impressing anyone by just writing down, she needs to work 47 hours. Who are you impressing? You're not helping anyone learn anything. It, it's pointless. I want to have a presentation where I can learn, I can help someone else to learn from that and to improve when they see my answer. And myself when I look back at it, of course. Writing it out gives me time to remember what I did and use it in the future. That's a beneficial way. I don't know what the answer is. I don't care what the answer is. It comes out as a result of my process. And then we have the beloved ratio equations. Oh, so good. If there's one thing to know, it's ratio equations, because who hasn't had to convert units or um, something like different currencies, all kinds of different things. So useful. And the ratio equation just gives me a more detailed way to understand why when I convert between units, do I sometimes multiply? Why do I sometimes divide? If I look at exercise 16, 22, and 23, for example, some people, and I've met them, they look at me after I do those questions, and they say, "Well, I knew to multiply by 0.64, or I knew to divide by this." That's great, but do you understand why? And can you adapt that to a completely different question, perhaps? No, they have nothing. And you're not impressing me knowing the answer. What impresses me is understanding the concept behind it and then adapting that to many, many more complicated questions. Knowing the number means nothing. Understanding how the number is obtained, now that is something I can actually use to better myself. But they're all very similar. So the ratio equation setup is, I'm trying to think, it's just an option, a strategy to be aware of when the equation looks this way. If the question doesn't ask, set up a ratio equation and demonstrate how you get the answer from this, then you can do whatever you want. You still have to justify and show your work, but take note of the question and follow what it says. Sometimes it says just set up the equation, don't solve it, just do the translation. Sometimes it says less, says more, so just follow those restrictions in a test question. Like these questions here, we obviously want to set up the ratio equation in order to practice, but they never actually say how I should be doing it. Yes. So lots of,
Steven,
yeah.
so when I did the cross multiplication, I found out that my numerator and denominator was switched comparing to your answer keys. I still got the same answers though.
Yes,
So is
no,
that
that's
okay?
totally fine. As long as you are consistent when you set it up. If,
Okay.
for example, I'm just looking at one here, if I'm looking at dollars to pounds, then I have two options for sure, but I still need to be consistent. Let me demonstrate. Yeah, that doesn't matter. It matters, but you have some room to move. If I have, what is this question? I have my exchange rate 0.64 pounds to a dollar. Okay. So if I have two choices. One is I say 0.64. Does the pounds go in front or behind? Why can I never remember this? Whatever. I'm just gonna not not embarrass myself and write pounds. I don't work with currencies a lot. Correspond That number corresponds to $1. Now I set up my other amount, $20,000 here, and whatever I want to call the variable, that will be number of pounds. I set up my ratio equation like that. If I've done it in a line, then pounds have to be with pounds, dollars with dollars. Or I can go and put the reference pair in a fraction. Then I'm stuck to pounds being at the top because I follow the pattern of where the reference pair put the different units, and $20,000 would go with that, and I set up my ratio equation like that. They're going to be the same thing. You see here when I cross multiply, the 0.64 multiplies with the 20,000, 0.64 multiplies with the 20,000. So in the end, the answer is going to be the same. I just can't, if I take the left option, pounds in one line, dollars, I can't do then dollars first and pounds later. That's not going to work. If I put them on top of each other, I can't then swap dollars to the top, pounds to the bottom. That's not going to work either. So there is some consistency that's required, but which one you choose, it's all the same. Doesn't matter at all. Not even a little bit. Sometimes the right side makes more sense if I'm talking about dollars per liter or something like that. It might make more sense to make it a fraction, or miles per gallon, things like that. Other times I like the left side. It doesn't matter at all. There's no danger flipping between them even, as long as you remember to keep that consistency. Lots of problems to work on. Good times. Then we have some more variables and equations, which are just, how should I classify them? Just the next step, really, in terms of complexity. Yeah, not a big step, but a step with multiple quantities needing representation. Not a ratio equation necessarily. No, actually, I don't think any of them are ratio equations. I don't think so. And it's just a matter of building that experience. Some are more complicated, like the birds, small bird, large bird. I definitely have to slow down according to the complexity. Some are more straightforward. It's just a matter of building the experience. Yeah. Where are we going? Oh, that's the end. Wow, I have no problems on this. That is shocking. Wow. All right. So, I mean, because our intended career path in general stops at grade 7, I'll say, variables and equations don't play a big role. They are there, and we try and introduce those concepts early, having some symbol represent a number, but we're definitely not getting into equations and solving equations very much. Especially these days, things slow down more and more. You can't get through what the curriculum says you have to, and as a result, you go at a pace that the class requires, and that's usually slower than the ideal. So as a result, the algebra um, has to wait longer and longer. So we aren't gonna. I doubt if you'll even have this level of question. Really, that maybe grade 7, but practically speaking, not really. I just need to be prepared, and it's definitely at the end of what I will probably see in a classroom or have to talk about, if at all. So, with the more variables and equations, I just want to have some examples to show you where our stopping point is. Perfectly manageable. It's just practicing the translation some more. I could break this up very nicely. Instead of asking the whole question, I could just ask, what is the total number of biscuits that dogs get? Can you just represent that? That's a perfectly good question then. It doesn't have to be the full question every time. I'm still practicing that translation, words and concepts into a mathematical expression. That is the key thing. Whether I put a ratio equation spin on it, whether I ask a full question like these, it's the translation that's the more important thing. Problem 16.12. 16.12. Yes, let's read through this first and see what is a plan that makes the most sense. A group of 53 people go to a holiday camp for 30 days. They need to buy enough sugar. Okay. They read in the book that the average consumption of sugar for 7 people is 25 kilograms a week. However, they can only buy sugar in bags of 2 kilograms. How many bags will they need to buy? It's nice. It's nice. It's definitely not a one-shot question. There's a lot of different things happening. I ultimately need to get up to 53 people and see how much sugar 53 people will need. And I need to know how much sugar 53 people will need for 30 days. That's a lot of sugar. I don't know if people should eat sugar this much, but whatever. It's not for me to say. So I need to, how shall I say, scale the reference pair. Where's the reference pair? The reference pair is the 7 people needing 25 kilograms of sugar. That is ridiculous. I can't get over this. Sorry. 7 people, 25 kilograms of sugar, 7 days. So the reference pair, I'm really connecting 3 units, number of people or people, kilograms of sugar, and days. Yes. Now, what is my plan of attack going to be? I'm trying to stretch this out so people can actually contribute instead of just sitting back, waiting for me. We don't learn as much. So I'm trying to go slowly, pretending to think, because you're right, there is a lot of different paths I can take. Which path, or at least a first step? Should we upgrade the people? Should we upgrade the number of days? One of those two, right? I have to pick one. I want to get to 53 people and 30 days. So I'm going to have to scale them both up. The fact that they're both 7 is coincidental. It might not always be that simple. Which one should we do first? Going people or going up in days?
Don't we have to figure out how much 53 people eat in a week? Because if we have 7 people.
That's what I'm
and-
saying. But I don't have to do people first. I can go 7 people in 30 days. I can go days first. But obviously, you want people first. That's perfectly good. So do I. So let's say the following. I can't get my pen to work. Oh, let's make a new page. Definitely 53 people makes the most sense for me as well. So what do we know? We know that 7 people is my units. I'm going to do it in a line because I think that's how the video does most of it. We'll need 25 kilograms. And we're going to do a week consistency so we don't have to worry about the week. We want to know 53 people will need or correspond to how many? Let's call it X. X kilograms. Now, for the sake of convenience, I'm not going to bother defining it, but we totally could. I can squeeze it in up here. We probably should. Let X represent the amount of sugar 53 people need in a week. Everything here is 1 week. We can't adjust easily. One could, but if we break it down nice and simply, we don't want to adjust 2 units at the same time. Are there shortcuts? Of course there are. Do I want to do them right now when things are a little shaky? No, not at all. Okay, so here is my ratio equation. And I get rid of my arrows, putting an equal sign between them. And I cross multiply. 7x equal to, what's 25 times 53? Let's find out. Uh, 1,325. So I divide both sides by 7, and x equals, oh, it's not going to be a nice number, is it? Yes, it's an unpleasant number. C7 is never nice. 2857114, and actually that whole thing repeats. Okay, now that's a good thing that it was an ugly-ish number. Not that I judge numbers. Because I don't want to round this to a 3 and then use it in a future calculation where this rounding error could get worse and worse and worse. And rounding is so hard to keep track of. Actually, it's nearly impossible to perfectly know what this rounding is going to have effect on in the future. So it's better to not round anything unless it's your final answer. Now on your calculators, you will have a memory button and stuff, so there's no real downside here. Okay, so this then means, so let's just write a sentence to see what we have and what we still need to do. So 53 people need 189 point, let's say here approximately. I can round it in my informal sentences, but I know that if I'm going to perform a calculation, use the actual number. Kilograms of sugar in a week. Let me just fix this horrible writing. In a week. Issue is a week. We've just kept the week constant, but that's not really what we're looking for, is it? We're looking for 30 days. Now I need to scale up the amount of sugar from 7 days to 30 days. This is a ridiculous amount of sugar. Who eats this much? Next, we can use another variable. For me, I like for this ratio equation setup, I like setting it up first and then going up and defining my variable. It just feels nicer to me, as long as it's done. No one knows the order in which I wrote these things. So the people are now consistent. So throughout, it's going to be 53 people. I can only change one thing. Apparently, I can't change my sloppy writing. That would be nice. The people don't change. It's going to be 53 throughout. So I need 189.3 kilograms. That corresponds to 7 days. Now I write a rounded number here. I have to remember this is not accurate. How many kilograms will correspond to 30 days? I feel like I'm doing something wrong because this is an obscene amount of sugar. But let me know if that is the case or it's just my bias. Now that means y is going to represent the amount of sugar for 53 people in 30 days. Yeah, this does not sound healthy in any way. I don't know if I can't remember if I just made this up in terms of numbers or I actually borrowed the question from a book. I can't remember. Let's just go with it. No one says the people come back from the camp. Maybe it's a sugar coma camp. Who knows? So then I put my equal sign in between. You go to the camp. You do not come back. Sugar camp. Cross multiply. Yeah. And I have, because the 7, it's going to look very similar to the top one, but it's just coincidence. They use 7 days and 7 people. Shouldn't actually be the same. 189.3-ish times 30. I get exactly, now I don't need to go crazy, but I can actually use my original calculation instead of the decimal and say 1325 divided by 7 times 30. 1325 divided by 7 times 30 equals, then the decimals are all done for me. And now I know precisely it's 5678.571428, blah, blah, blah. And now I double check. Is that exactly what I'm looking for? Well, sort of. I know the 2 kilogram bags happen afterwards, but I'm close. So I have 53 people, I have 30 days, and this can't be done. I'm not done, right? Divided by 7. It's like, whoa, I have to divide by 7. Now the double 7 is just a coincidence in the problem. I don't want to look for a pattern where there aren't any. Let's do that accurately. 39750 divided by 7 gives us 811.224489, blah, 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 blah. So I'm not going to say we, because we do not need that much sugar. They need approximately 811.2 kilograms of sugar Now, I don't need a ratio equation for the next bit because they come in bags of 2 kilograms. Number of bags, that's basic intuitive understanding of division. 4 bags of 2 kilograms each. 811.2 divided by 2. Let's do it exactly. 39750 divided by 49 divided by 2. That gets us to 405.6122-ish. So they're going to need, again, practical rounding, at least 406 bags. I'm not sure. Maybe you get an extra truck or something. There you go. I guess it's funny if it wasn't sad. I'll zoom out like that. Hopefully you can still see it. It's a little small perhaps, but just to see the whole question. Now, of course, if you have prior experience with unit conversions, ratio equations, yeah, there is a shortcut, of course. There's a shortcut to almost everything. But shortcuts do not promote understanding, and that's what we're trying to develop. So I don't want to do that. In the second course, there are then opportunities for things like that, and to go in depth with unit conversions a little bit more and so on. But that's not our goal here. Our goal is that translation and slowly finding our path towards the answer. If there's one thing I would like to teach kids, it's to not obsess about the answer, but rather just move towards it, and it'll come eventually, and have that patience. And they do not seem to have that naturally, but it's a very important skill, life skill that goes beyond math problems. You have a problem in life, you might not have the answer, but work towards it, and you are improving. Or something like that. What do I know?
Steven, I have a question.
Yes.
So, like in this problem, how I try was like I first figure out like how much each person needs of sugar per day.
Yeah, you could totally do that. Yeah.
And then I like multiply like people and the days and the sugar amounts equal like 2x, and the x was like the total bags they need to buy.
Yes, and of course that's there's nothing wrong with that. My immediate reaction from a teaching point of view, it depends on your audience, of course, is it doesn't explain it as clearly if a person has zero experience with problems like this. But as an answer that you do, it's perfect. There's nothing wrong with it. But we always have those two sides, right? How would I teach this, and to what audience, and how would I do this myself? Those are different issues. So doing it, perfectly fine. Don't worry about it. But I don't want to do it this way here, because what if there is someone listening that has no idea, that is barely holding on? Then I want to have as much detail and small steps as possible. But absolutely fine. Totally up to you.
Okay, because I felt like I had to use like the one variable in the questions, but I think it's
No, not at all. Because we really have, if you break it down, you really have two or maybe more questions in the seemingly one question. It's not really one question. It could be an A, B, or C question. And then each one has its own equation, therefore its own variable, but it's not all in one. it is sequential. So then it's okay to have multiple variables. The time where I talk about ideally aiming for just one variable is where I'm going to do this all in one go. There's no multiple steps. There's one equation, and I therefore need one variable. That's not what happens here. I broke it up into smaller steps to make sense of it for myself. Each equation has one variable, so that's totally fine. There's not simultaneous equations that I need to solve or anything like that, like it would be in the more variables in equations situation. Now, of course, that becomes more obvious with experience. And there's no blanket statement like always go for one variable or you can never do this. It depends. Everything depends. I think the most important thing is to just take a path towards the answer that makes sense to you and that you can explain. And that's fine then, yeah.
Thank you.
Any other thoughts? It's only 5. What are we going to do for half an hour? I don't know. You tell me. What do we do?
I guess like could you go over like the general method? I'm still like a bit confused of like knowing like where to put like variables and like how to like make the equations, I guess. I know it's really
Yeah, I think one of the last ones, like exercise 1624, is general. Yeah, it's not a specific kind of equation. It's really just emphasizing the translation. So we can certainly do that. And then we will, oop, what did I just do? We will look at the chip model as well, sure. Exercise 16 point, what did I just say? 24. Yeah, the sooner I see it as a translation, personally, the better off I'm going to be. All right. 56 biscuits are to be fed to 10 pets. Each pet is either a cat or a dog. Each dog is to get 6 biscuits, and each cat is to get 5 biscuits. How many dogs and how many cats are there? So that middle line, I'm really just sort of getting an idea of the question. I'm not actually looking at the detail. I'm waiting for the question sentence. How many dogs and how many cats? Oh, there we are. Okay. So I'm going to pick one. The one that happened first was dogs. Let's go. What do you want to call it? Should we always just use an X? It's so boring. Let's, fine. Let's go X to represent dogs. How do you feel about that? And I'm not talking to anyone specifically. Yes, no, maybe, sometimes.
yeah. I understand that part.
So there is a difference between what we want to say and what we are saying on paper, which is important when I'm teaching little Timmy about a variable for the first time. X is not an animal. X is a number. And my sentence needs to clearly reflect that as a reminder to myself and anyone who reads it. So that sentence is not correct. X represents the number of dogs. Very big difference. Though we all knew what we were trying to say, what we were saying actually wasn't the same. Then, rule of thumb, if I can get away with one variable, I'll try. Now here, I need to know 2 things in one go. How many dogs and how many cats? But I know there are 10 pets. So if X is the number of dogs, then the number of cats has to be represented by 10 minus x. I'll put a bracket around it. Why not? So it's really just that representation question so far. Now, based on the information they give me, they're talking about biscuits. Each dog gets some biscuits. Each cat gets some biscuits. There are 56 biscuits in total. So let's write some more stuff here. On the way to setting up the equation, people want to write the equation in one go because it's impressive, I guess. I don't know why. And then they're shocked when something goes wrong. Well, break it down and build up to it like everything else. So all dogs get how many biscuits? If I can spell, or I can spell, I can't write. How many biscuits do all the dogs get? If I have X number of dogs and each dog gets 6 biscuits. No, it's not silence.
6x.
6 times X. And all the cats get how many biscuits? Can cats and dogs eat the same kind of food? Oh, all right. Maybe they're multi-pet biscuits. I don't know. The more we scratch at these questions, the more things we discover. If each cat gets 5, and there are this many cats, it's 5 times the number of cats. I don't need to simplify it right now. It's a simple enough expression, so I don't worry too much. The fraction one way back, that was needed to simplify that maybe for my peace of mind. And then they tell me in total we have 56 biscuits. Well, that's my equation right there. So if I take the total number of biscuits for the dogs plus the total number of biscuits for the cats, and I literally just copy these down, that has to total 56. And we've translated the information that they give us into a mathematical sentence. But give yourself the help and the small steps when you need it. Someone else might think, I don't know, just write that in one go and simplify it and do everything in one go. Sure, if you know what you're doing, that's fine. Smaller steps make each step easier. I'm not impressing anyone by writing less. Actually, you're impressing me by writing more, because I know the benefit that it has when you have to teach something like this. So now I need to simplify the left-hand side before I can solve the equation according to its grammar rules. Multiply the 5 in to get 50 minus 5x, and the right-hand side stays the same. I'll merge the like terms to have just 1x. I don't write the 1, and we all understand what that means. I subtract 50 on both sides to get x equal to 6. Now that isn't my complete answer. I have to translate it back to English. I'm just going to do it over here, since otherwise I won't see my sentences at the top. So there are 6 dogs, because that's exactly represented by x. And there are 10 minus x, 10 minus 6 for cats. And we're done. But again, I didn't care to know at the start when I read the question what the answer was. I actually make a point to not even think about it. I follow my steps, step 1, step 2, step 3, step 4, and I'm confident that it'll get me there if I just take small enough steps to not make a little mistake along the way, of course. And then there is really nothing scary about this. It's actually comforting to me to know that if it's a variable in equation kind of problem, of course, not all problems are, whatever it is, I'm going to get there. It might just take me a while. I have to go through my journey, but I'm not worried at all. And that low stress feeling gives me confidence and less anxiety, and all good things come from that. In theory, at least. If nothing else, our main goal in elementary school is to get rid of or avoid anxiety. But that is way easier said than done, and I can't say that I am always successful. Let us see. Chip model. I'm not going to go to the chip model. I'm just going to make one up. Chip model. Good times. So there, our goal now is to think on the most basic level, almost. What is the hardest chip model question? The hardest one, I think, is the one that we can't see what we need to do. Now, when we add 3 plus -2, adding is never going to be the issue, right? I guess I have to make my chips here. I'm just going to pick circles and color them instead of making the circle a color as well. Just going to be a little easier for me. Negative, positive. Okay, so I have 3 positive chips. Color is always fun. It's amazing how we respond to color. So I'll just squeeze it in here. I have 3 together with -2, which will be 2 negative chips. 2 negative chips. And the instructions, the intuitive instructions for addition is to just pool all this together. All together, I have this much. That's what I have. But I can clean this up a little bit. Like if, I don't know why I always talk about chickens, but I'm thinking about sort of the most basic situation back in time when people were just trying to keep track of their farm animals or something, or trade small amounts. That if I see 3 chickens running around in my field, but I actually owe my neighbor 2 chickens, how many chickens do I really have? I have only 1 chicken. So I might see 3 blue chips, but I have 2 negative chips, and after I've cleaned it up, settled my debt, I have 1 blue chip. So some people like the chip model because it's closer in its connection to the concept of owing someone, the concept of debt, which I guess sadly is a practical thing kids need to learn, though mine don't have any concept of that. So this better illustrates that, where the number line model doesn't really. Then if we have an example for subtraction, like, what shall we say? Maybe we can go -3. Let's take away 2. There's no need to draw that many chips. That means I have, we should write our answer, shouldn't we? Equals 1. Not that that was the challenge, really. We have -3. That means I have 1, 2, 3 negative chips. Ooh, I can go for chips. That'd be nice. Getting hungry. Anyway, focus. Then my instructions say remove 2 positive chips. But I can't. I need to take away something that I do not see. In order to see it, I need to bring in some positive negative pairs. A red and a blue. Red. What happened to my pen? And a blue. Essentially not changing what I have. Now I can physically remove them. You are gone. Gone. And I have left, obviously, 1, 2, 3, 4, 5 red chips. And all that's left is to color some circles. Always a good time. Hopefully easy. I mean, it's designed to be as basic as we can go. Yes. So just make sure that you do not, did we have one like that? Like this first one. You do not say, oh, well, this is 3 minus 2, so therefore have 3 blue chips and remove 2. No. Well, I mean, technically yes, but that is not what the question is asking. The question is asking that I illustrate the chip model in its most basic form, not use mathematical properties allowing me to simplify this and then do it. No, 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 no. Not what we want. And I guarantee you, someone's going to do it. It happens every time. Regardless of how many times I give warnings, always someone says, what does he know? I'll do what I want. And it's not a question of being technically wrong. Well, it's not a question of being wrong. It's a question of being technically wrong according to what that question is asking me to do. I guess we will end with a favorite, fraction division. Why not? Now, I'm not going to draw a lot of fractions. I'm lazy. Rectangles, I mean. So there's no need to make this big. Let's get something where we can actually fit stuff in. And divide by, I don't know, what should we divide by? 5/6. That's a nice one. So I have my first number. Let's get drawing. And I'm breaking it up into 4, if you squint, equal pieces. Now, because it's division, I know I'm going to eventually break up all of these whole rectangles anyway, so I might as well get to it now. But technically, in some cases, you don't need to break up all of them. But I know that's going to happen anyway, so I am doing it. I have all of this first rectangle. I have all of the second rectangle. I have a little bit more. There we go. Now, so 2¼ Now I need to understand the concept or the instructions that division is giving me. And those instructions say, count how many times a group of 5/6 of a rectangle can fit in here to what I have. So my group size is the second fraction, but it's in reference to a whole rectangle. That means I just need to see a whole rectangle to make sense of the group size before I can worry about the pink, what I have. I'm just going to pick the last one here. I need to break this up into 6 equal pieces. I'm going to go rows because I've already used the columns for something else. Now, when I do this, I don't see any pink. Pink does not exist for the next few seconds. 5/6 means take 5 rows out of 6. That would be 1, 2, 3, 4 in a row times 5. That's 20 little pieces. They're not pink, they're just little pieces. So that's my group size. So now I want to see how many times can I fit in a group of 20 little pieces how many times I can fit this in. So I need to split the other rectangles as well so I can start fitting it in. Just check, can everyone still hear me? I have a very flimsy switch on my microphone and I'm always worried that it breaks. Okay, good, just checking. It would be unfortunate if so close to the end something like that happens. Now, just a reminder, sometimes my squiggles don't really cover every little piece, but of course I have all of these, right? All of this. Okay, good. So let's go maybe blue. I want to count 20 pieces. Oh, well, we have some to work with. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's not bad. 20 like so. So that's my first time that it can fit. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So all of this is another time they can fit. So 2 times so far. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, so close. So we can fit in these groups of 20 into what we have 2 times. Oh, come on, that's ugly. 2 times with, what did we say? 14 pieces that are pink. Left over. So this is the base level of the method. I am not going to count my total, then do long division on that, and get 2 and 14, though it is very close to the same. I want to draw things, fit them in, go as basic as I can. So we can fit the group 2 and 14/20ths of a time, if you will. The answer to a division question is different. It is in reference to how many times I can fit it in, not in reference to a rectangle that I've seen. It's a little weird. But don't dwell on that for too long. And there we go. Now, of course, you have a calculator. You can verify that this is correct. I did not do it that way because I don't want to lose any marks. A very nice question to end with. It's nice. There's some color. Good times, good times. Any last words? That you would like to share? It's good to share. Sharing is good. The same format for the test tomorrow. Everything's the same. Quiz 3 and 4. And then I will check to see who has emailed their portfolio assignments, what's missing, and so on. People are typing. I'm just checking.
I think that's Matt's.
Oh, he's typing in for someone else. Fair enough. I'm just not sure. I just want to end it if a message is going to come, but they might be typing to other people. Fair enough. All right. That will be it until our test tomorrow.